data sheets, you have to insert a SIM card, a valid SIM card that is provided by a certain service provider. You have to insert a SIM card in that module in order to enable it to connect it to the nearby base station. Now, whenever you insert a SIM card in a GPRS module or in an LTE module, it acts similarly like a user to that particular network, because the network has to allocate a certain radio frequency channel to that particular module in order to enable it to communicate via the base station to anywhere, whether it is the service provider or it directly transfers the data to a web server, whatever the case is. But still, if you insert a SIM card into that module, it just behaves like a user. Now imagine in a certain neighborhood where there are maybe hundreds or thousands of houses, and it is a very congested area, and let's suppose it is covered by just one base station or maybe two base stations for that matter, and you install a GPRS module in all of the smart meters. Now that means that you have burdened the network with additional 1,000 or 2,000 or whatever the number of users is, and then in addition to the actual mobile phone users who are making voice calls or they are accessing the internet, they also have to take care of the additional users in the form of smart meters, because they have to also use the cellular connectivity option in order to transfer the data to the utility provider. So that puts a big question mark on the capacity of the network, whether the network will be able to provide enough capacity to that particular, to a large number of smart meters. And it is not just, the smart meters in the smart grid. I'm going to come towards, a bit further as we progress further in the presentation. I'm going to discuss machine-to-machine communication. It is also, as you know, a very active research area these days. And machine-to-machine communication does not only deal with the aspect of smart meters, because smart meters, basically, it is also an embedded device. And whenever you talk about embedded devices and the communication between embedded devices, it is basically machine-to-machine communication. So machine-to-machine communication does not only cover smart meters and the idea of smart grids and embedded devices and current transformers and all those modules communicating with one another. It takes into account all the embedded devices and all of their applications. For example, you might have heard of intelligent transportation systems and the use of wireless sensors and other types of sensors in intelligent transportation systems for fleet management, for congestion control, for dynamic traffic light adaptation, for statistic collection, recording the number of vehicles through a certain intersection. All of those things, they come in the category of machine-to-machine communication. And in that particular case, you also have to use one of the backhaul networks to transmit the data from a certain either traffic intersection or from a certain highway. And that is an additional burden on the backhaul networks. So in the future, they are talking about billions of devices, embedded devices in place, calculating and gathering different types of information, whether it be from smart meters or from in intelligent transportation systems or smart health applications. You just name it, there are so many different applications. So when you have billions of embedded devices, how is the data transfer going to take place to a centralized location? What is the means for that? Because currently, we don't have enough capacity to cater for such large number of devices. And talking about a very large number of devices, we might also, we have to use a certain scheduling algorithm in order to handle the data. If we have a very large number of residential areas in a certain location and every one of them have smart meters installed in them, so if the data is coming from so many different sources to one or two data concentrator or aggregator modules, it has to sort out the data in some manner, because some of the possible priority criteria can be anomaly detection. Just like I said, if somebody hooks a wire to a distribution line and if you have a certain state estimation algorithm in place and it detects that particular instance, so that information can be prioritized on top. That has to be reported to the utility provider and it has to address that particular issue. Then we have the manual meter reading request. Let's suppose the smart meters are scheduled to automatically send the electricity usage to the utility provider after a certain time period. But the electricity utility provider should also be able to manually request a certain smart meter to check the reading. So if there is a manual request from the utility provider, it should be given priority. Then the automatic meter reading data, and then the energy usage statistics from a certain household. So now, when we talk about smart grids, and sometime a little while ago I just discussed the idea of different appliances in a certain residential area or in a certain household. Now, I said that if we attach, a wireless, if you embed a certain wireless module in that particular appliance, then it can transmit its electricity utilization to a certain. It can either transmit it to the smart meter, or you can have a certain wireless monitoring device which can connect to all of these appliances, and it can record the utilization of each of those appliances, and it can then connect to the smart meter and transmit all of that data to the smart meter. So that data can then be sent in the form of statistics to the utility provider, and then the utility provider can have a more detailed idea about the energy consumption habits and the amount of energy consumed by each subscriber or consumer. So with smart appliances, we can have real-time energy utilization and efficiency information conveyed via a suitable wired or wireless interface to the access point or a smart meter. It can be remotely monitored by the utility provider, and it can be remotely configured by the vendor. Let's suppose a certain vendor has manufactured a certain appliance, and maybe it requires a certain software update or something like that, or it needs to be remotely configured. So that can also be done if it is connected to a certain network. That might be easy. The operation can be scheduled according to a dynamic pricing plan that suits the requirements of the consumer while lowering his overall tariff. That's also possible because the electricity utility provider can also control the appliances and optimize the utilization of those appliances in such a manner that, just like I said, you have the integration of renewable energy sources, so the cost of electricity generation can vary throughout the 24-hour period. So based on that particular variation in cost, the electricity utility provider can dynamically prioritize, and it can control the the usage of those appliances in such a way to optimize or reduce the tariff for the end consumer, while also balancing the demand. So he can distribute the electricity consumption in such a way that in peak periods the burden on the electricity grid is reduced.